Ever tried solving a Rubik's Cube or a Sokoban puzzle and wondered how an AI would tackle it? What if I told you scientists are building machines that don't just solve problems, but understand them? Let's break down a game-changing idea called CRTR, short for Contrastive Representations for Temporal Reasoning, and see how it's teaching AI to think like humans. Here's the problem. Traditional AI is like a student who memorizes answers but doesn't grasp the lesson. It relies on two things: perception, recognizing states, and planning, figuring out actions. But planning, it's usually brute force, like trying every possible move in a puzzle. It's slow, messy, and not very smart. The real issue: AI struggles with temporal reasoning, understanding how things change over time. Imagine solving a puzzle by only looking at individual pieces, not the whole picture. That's what happens when models focus on spurious features, like the layout of walls in Sokoban, instead of the actual rules. This is where CRTR steps in. It's a new method that teaches AI to see the forest, not just the trees. By using contrastive learning, CRTR trains models to distinguish between states that are connected in time, like steps in a puzzle versus those that aren't. Here's the trick. CRTR forces the model to compare states within the same journey. For example, in Sokoban, it learns that moving a box forward is meaningful, but the color of the wall behind it is. This eliminates distractions and focuses on the actual dynamics of the problem. And the results? CRTR crushes complex tasks. In Rubik's Cube, it solves puzzles using fewer search steps than traditional methods, though the solutions might take longer. But here's the kicker. It doesn't need external search algorithms. It's all in the learned representations. This isn't just about puzzles. Think of self-driving cars, robotics, or even medical diagnosis. If AI can better understand time and sequence, it could revolutionize how we solve real-world problems. So what's next? The future of AI might not be about brute force computation, but about teaching machines to reason through time, one step at a time. Thanks for watching, and let me know your thoughts. How do you think AI should handle time? Hit subscribe for more deep dives into the science behind the tech. Ever wonder how AI tackles super tricky puzzles or learns to navigate complex tasks? Today, we're unpacking a mind-blowing study that's changing how machines think, and why it's a big deal for the future of artificial intelligence. Let's dive in. Picture this: an AI trying to solve a Rubik's Cube isn't just about memorizing moves. It's about understanding time, sequence, and structure. Traditional methods often rely on surface-level clues, like colors or positions, but they struggle with the why behind each step. That's where this research shines. The team introduced CRTR, short for Contrastive Representations with Trajectory Rewriting. Think of it like teaching a robot to read a story, not just memorize the words. CRTR helps AI grasp the flow of actions, so it can predict what comes next, even in chaotic situations. But how did they test this? Let's break it down. They ran thousands of experiments, tweaking everything from the AI's brain size to how it processes information. For example, they found that a model with 512 hidden units, like a supercharged brain, and a 64-dimensional memory space worked best for puzzles. It's like finding the perfect recipe: too little flour and the cake collapses, too much and it's dense. They also played with learning rates, the speed at which the AI absorbs new info. A rate of 0.0003. Perfect for most tasks. But in one game, they had to slow it down, like adjusting a radio dial to catch a clearer signal. Here's the cool part. They tested different ways the AI learns from its mistakes. One method, contrastive learning, taught the AI to compare similar situations, like a detective linking clues. But when they added a backward loss function, letting the AI learn from after an action, it blew the competition out of the water. Pair that with math tricks like the dot product, and the AI started solving problems faster and smarter. The results? In the Rubik's Cube, models using these techniques solved puzzles in half the steps compared to old methods. In Sokoban, a classic puzzle game, their maps of the game were way more accurate, no more random wandering. It's like giving the AI a GPS that updates in real time. But why does this matter? Imagine teaching a robot to cook. If it only memorizes recipes, it'll fail if ingredients change. But with CRTR, the robot understands why certain steps work, adapting to new challenges. This isn't just about solving puzzles. It's about building AI that thinks, learns, and adapts like humans. And here's a twist. Even without explicit step-by-step plans, the AI outperformed others. It's like a chef who doesn't follow a recipe, but still creates a masterpiece. CRTR's ability to distill temporal dynamics into meaningful representations is a leap forward in AI's quest to mimic human-like reasoning. So what's next? The future of AI might not be about brute force computation, but about teaching machines to reason through time, one step at a time. Thanks for watching, and let me know your thoughts. How do you think AI should handle time? Hit subscribe for more deep dives into the science behind the tech.